Okay guys, so welcome to the last video in which we're going to review the content for the test this week. Okay, so we're missing just two topics, and it's this one: in and out machines, tables, and rules. And I know that you guys were good in this. You mastered mastered this when we did it, but we did it so long ago that I wanted to go back to it really quick. And the next one, the final one, is lines of symmetry, which was the very last thing that we saw, and we were kind of struggling with that too, and I wanted to help you with this. So let's take a look at in and out machines, tables, and rules very quickly. So remember that the whole concept of in and out machines or tables or rules is whether you know what's going on. All we want to know is, are you aware of what's going on if I give you a number and I turn that number into something else? What happened in the middle? For example, let's take a look at this example here. This is the easiest questions that you're gonna get, okay? Where I give you a number and I say, for example, let's say 5. 5 goes into the machine, right? And I tell you that 25 comes out. And I ask you, what is the rule? Well, when I talk about the rule, when we talk about the rule, actually what I'm asking you is, do you know what operation happened inside the machine so that this 5 turned into this 25? And if you only have that one question, 5 into 25, you could tell me a lot of things. You could tell me, well, Mr. S, maybe I added 20 because 5 plus 20 is 25. And I say, yeah, you're right. And you can tell me, Mr. S, maybe I multiplied by 5. Maybe I multiplied by 5 because 5 times 5 is 25. Okay, so there are different things that can be the rule if you only have one question. Now, if I show you, for example, 6 and 30, then you say, whoa, wait a minute. I know that 5 times 5 is 25. And I know that 6 times 5 is 30. So in this particular machine with those two questions, the rule is times 5 because the rule always needs to be the same. We cannot, if I give you different numbers for a single machine, you cannot tell me that they have different rules. There has to be a rule that controls all of it. And in this case, by the numbers that I'm giving you, the rule is times 5 because 5 times 5 is 25, 6 times 5 is 30. And in the same way, if you know this already and I give you, for example, this, and I tell you that the next one, the rule is times 5 and the out is 45, you could tell me the in. You say, what number do I multiply times 5 to get 45? Oh, I know that's 9. Okay, 9 times, excuse me, 9 times 5 is 45. So this is the most basic question that you can get with in and out tables, where you have an in, you have an out, and you have to find the rule. And if you have the rule, you can find whichever ins or outs, whichever one is missing, because you already have the information. Now you can also be shown a table like this. These are a little bit more complex, but it's the same thing, okay? Where they give you 3 columns. The first one is called position, the second one expression, and the third one value. Well, the position is nothing more than the in, and the value is nothing more than the out. Okay, this is just there. When they give you this, when they give you these kinds of tables, it's usually based on a word problem or based on maybe the way they give you the information, but it keeps being the same thing. So if the position is the in and the value is the out, then the expression is going to be your rule. Okay, so the important thing here, guys, is that the part of the expression that turns the in into the out cannot change. It has to be the same because the rules always have to be the same. For example, if I give you the positions 1, 2, 3, 4, 5, and 6, and I gave you here the value as, say, 6, 7, 8, 9, 10, and 11. Okay, and I ask you, okay, so what is the expression? Well, you have to find a way that the 1 turn into the 6. You have to say, how do I turn a 1 into the 6 that is the same way that I turned a 2 into a 7? And you say, well, if I add 1 plus 5, I get 6. Okay, so if I add 2 plus 5, I get 7. Yes. If I add 3 plus 5, I get 8. 4 plus 5, I get 9. 5 plus 5, I get 10. 6 plus 11, 6 plus, wait, hold on. Oh, sorry. 6 plus 5, I get 10. So in this table, my rule is plus 5. This is my rule. But the expression, when they ask the expression, they're just saying, okay, so take your position and add the rule, what do you get? Take your position, add the rule, what do you get? Take your position, add the rule, what do you get? So the rule keeps being the same, plus 5. It's just that they're asking you for the expression, so you just bring the position, the number in the position to the column of expression, and you express it like that, okay? But again, it's the same kind of computation. You're always going to do the same kind of thing, okay? Remember, the key is, how do I turn the first number into the last number? And that's going to be your rule or your expression, okay? And remember, the expression cannot change. I couldn't have had a plus 6 here, or 5 plus 7 here, because if I decide, or if I find that a rule is plus 5, it has to fit for every single part of that table. Okay guys, so that is in and out tables, machines and rules. We're gonna spend some time, maybe 15 or 20 minutes in class, reviewing this before the test. Okay, now finally this is the area where we kind of struggled a little bit last week, and it's in symmetry, particularly symmetry lines. Okay, so we learn in class, and we spend a whole day learning that symmetry of a shape that has symmetry means that two sides of that shape are mirror images of each other. That means that if you draw a symmetry line through a point in the figure, through a part of the figure, if you fold that figure along that line, you're going to have two equal parts. For example, look at my hand. So let's say that I draw, let's say that I make a vertical line from north to south through my hand, okay? If I was able to fold my hand like a piece of paper through that line, this side will not be equal to this side because I have a finger here, and plus this finger is not equal to this one. So if I fold this my hand by that line, the two halves do not match. So that means that my hand doesn't have symmetry, or is asymmetrical. Okay, it doesn't have a symmetry line through that line. So some shapes are going to have symmetry lines because they have symmetry. Some shapes will not have symmetrical lines because they are asymmetric. So there are two main types, or two main ways that you can ask about symmetry lines. The first one is, for example, they're going to give you a shape, say this shape. Oh, sorry. They're going to give you, my bad. It's not what I wanted to do. They're going to give you a shape like this, and they're going to ask you, does that shape have symmetry or symmetry lines? And what you have to do, and what we learn in class, is you're going to start with vertical lines. Okay, you're going to ask yourself, well, let me start with vertical lines. Whoa. Let me start with vertical lines. Remember, vertical lines are from top to bottom. So you're going to ask yourself, if I put this line anywhere in this shape, in this figure, in this shape, do I get two mirror images of each other? Well, if I put it here, this part here, if I fold through that line, this part here is not going to be the same as this. Same if I put it here or here or here. But if I place it right there, right smack in the middle, then you see, oh, this side is perfectly a mirror image of this side if I fold it through that line. So that is a symmetry line for that shape, and you can say, yes, the shape has symmetry through one line, okay? Then, once you know this, you can write, oh, one symmetry line. Now, you're gonna go ahead and try horizontal symmetry lines. You say, okay, let's see. If I put this line here, no, the top part is not a mirror image of the second one, of the bottom one, if I fold them. If I put it here, no, because I have an angle here. I have an apex here, a vertex, and here I have two. So it doesn't matter where I put, it doesn't matter where I put that vertical line, that horizontal line, I can't find symmetry. Okay, so no symmetry, no horizontal symmetry for this shape. Now you're gonna try vertical lines. So you're gonna draw a vertical line and you're gonna say, okay, let me see if I can place this anywhere that gives me symmetry. Oh, look at this, look at this. What if I put that line there? And if I fold that image through that line, do I have one side mirror image of the other? Yes. Oh, so you say, okay, so that's a symmetry line. And you're gonna find that if you do the opposite one, you're also gonna find symmetry. So the key about finding a symmetry line for a shape is just observing, visually inspecting the shape. You cannot just go ahead and look at a shape and say, oh, yes or no. You need to observe it, and you need to start drawing lines very softly with the pencil and asking yourselves, are those two mirror images of each other? And if you find that they're not, erase it, try another line. Okay? And always go vertical, horizontal, and then diagonal lines. Okay? The most common examples that you're gonna find is that of a square. Hold on, let me do a square, a perfect square, and then a rectangle. Now, a perfect square and a rectangle, you might think they're the same, but let's check. So you have a rectangle and you have a square there. There's a very particular difference between these two. So if you take this square and you draw a line from top to bottom, you're gonna find that that's a symmetry line. Yes, that's one, because this side is a mirror image of this one. If you draw a line horizontally, you're gonna find that yes, it has symmetry, because this part here is the same as this part here. Okay, I didn't erase the first line, so but you can actually tell that I did this one first. So two parts, one symmetry line, two equal parts, another symmetry line, and then if you do one from here to here, look at how interesting about the square this property is. This part here, this part here is a mirror image of this part here. So again, that's another symmetry line. And again, if you do this line from here to here, you have another symmetry line, because again, this part here is the same as this part here. So a square has 1, 2, 3, 4 different symmetry lines. Okay, let's take a look at the rectangle. So I take the rectangle and I'm going to draw the vertical line first. Okay, that is a symmetry line, because I can place it in a part where one side is a mirror image of the other. Good. Now, Let's do the horizontal line. Yes, I find symmetry line. I find a symmetry line because one part, this part, is exactly the same as this one. Now look at how interesting it is when I put my diagonal line. So this part here may look the same as this one, but actually if you fold through that line, if you fold a rectangle through that line, it's not going to give you two equal parts. And we're going to see this tomorrow when I mean we already did, but I'm going to show it to you again tomorrow when we do it in class. If you fold that shape, this part of the rectangle, the bottom part, is not going to be a mirror image of the other part. This angle here, when you fold it, it's going to end up here, and this angle is going to end up here. Whereas in the square, when you fold through those lines, everything fits in each corner. I mean, it's like you don't have anything out of place. So it is very important to understand the difference between a square and a rectangle. A square has 4 symmetry lines, whereas a rectangle only has 2 symmetry lines, a vertical symmetry line and a horizontal symmetry line. And tomorrow we're gonna practice more symmetry because I want you guys to get the symmetry of shapes really well. Okay, so there's one website that I'm going to link on my Canvas site for you to practice symmetry. Okay, so you can wait till tomorrow when we meet on the class, or you can go today to Canvas and click on that link to practice symmetry. So guys, this is the 4 videos, I think it was 4 or 5 videos that I put out. Every single question on the test is I mean, not every question on the test is on the videos, but you have everything that is included on the test, you have on the video, so you can go and review the concept so that when you find the question in the video, it doesn't surprise you. Okay, so that's it. I will see you back in the room, in the classroom. I'll see you tomorrow. Bye.